So after the excitement of yesterday, this talk will be hopefully no less exciting, but different. But you know, I think hopefully I am able to deliver it in a cohesive manner. I celebrated far too much yesterday, last night, and felt a bit fragile this morning. So, but yes, this talk is on GORM Data Services, and one of the coolest features of GORM 6.1 that we introduced, in my opinion. And I'm not sure how many folks are aware of GORM Data Services or are using them in their apps. I'm going to explain a little bit the motivation behind GORM Data Services and the background, and do some demos, and most of it's going to be live coding, so that tends to go wrong, but we'll see how it happens. Yeah, we'll have some fun. So yeah, like I said, on the agenda today, I'll do an intro to data services for those who haven't used them or don't know what they are or haven't upgraded to GORM 6.1 yet. Bit of an explanation of why GORM Data Services, what's possible with them, and hopefully we'll get to do a load of live coding and demos. So why do we have GORM, we have all those static methods, it implements so much for you. Why do we need data services, or why are data services a good idea? Well, a lot of users of GORM tend to not define their transaction semantics correctly. So what does that mean? Basically, if you look at this relatively simple operation to list a bunch of books, you can see that it's missing the critical at read-only line. And what are the implications of that? Well, Hibernate does automatic dirty checking of your objects, and in GORM we optimize that to the maximum, far more in Java. In fact, in Java, if you use Hibernate normally with Java, what Hibernate does is to check if your objects have changed. It will create a parallel array of your property values for each object that you read. And then when before exiting the session, essentially what it'll do is compare that in-memory array with the properties on your object to check if they've changed. That's with regular Java. With GORM, we're a lot smarter than that, because we're trying to solve as many problems and make it as high performant as possible for folks that use GORM. And we have a set of AST transformations that will essentially track the changes on your property, on your objects. So no in-memory arrays is stored in the session, and we already know what properties have changed from your objects, and we're able to optimize that. But still, Hibernate is still performing a check, and it performs a check unless you specify your transaction as read-only. So in this case, when you do book.list, if you've got 30 book instances, Hibernate will go off and even though you haven't actually changed them or done anything in your code, it'll go off and check all those 30 books and check whether they've changed to potentially flush those changes to the database, even though this operation doesn't seem like it should be writing to the database at all. It has to perform that check unless you specify read-only. So that can lead to problematic performance issues, particularly if you have a domain class with a lot of properties or you have a lot of data that you're reading. And a lot of performance problems we see in production applications lead back to incorrect transaction demarcation. In addition, users often don't correctly define joins. So, if you're going to need the data in your view or wherever you're going to use it, or when you're in your JSON or whatever it is, you should be using a join. Why? Because if you have an association, you are essentially at the mercy of the n+1 select problem if you don't. It's far more efficient to do your query in a single query with a join than it is to leave it to hibernate, to lazy load your objects. This is even more critical in. This will be even more critical in Micronaut, in fact, in the future, because in Grails we have traditionally continued to maintain a open session in view approach, which allows you to lazy load within your views your associations, but that has often led to performance problems. Really, you should be keeping your connections to the database open for the minimal amount of period, such that you read all the data only within the body of each service or controller action or whatever, so that you minimize the amount of time your connections stay open. If you return a bunch of objects and then reopen the session just for view rendering, which takes more time, you're essentially having your connections, your sessions, open for longer than is necessary and reducing the performance, the optimum performance level of your application. So yeah, joins are important, and most users lean on Grails heavily and don't bother defining correct joins for their data. Also, efficiency of update operations or write operations in general. So, if you get hold of a book instance, and then you set the title and you call save, it looks fairly innocuous, but the default configuration set up in GORM is to use optimistic locking and without dynamic updates. And what that means is that it'll produce an update statement that will update all the properties of your domain class. So even if you're only setting the title, the update statement is still going to write every single property, or attempt to write every single property. There's actually an option in GORM to configure, if you disable versioning and optimistic locking and enable dynamic updates, you can actually alter the GORM such that it only updates the title for an update operation. That still has other downsides, and maybe that's a longer talk that I could go into the details of GORM and how it behaves. But this fairly innocuous bit of code, if book in this case had like a dozen different properties, would produce a write that updated every single property of the book, which is less efficient at the end of the day. And then we have the emergence of more and more folks wanting to create applications that are multi-tenant. So what are the implications of that? Well, typically you want to run a certain set of operations against a particular tenant, and it gets really boring in GORM, having to wrap every single method call with tenant or with current tenant, or so if you're building multi-tenant applications, or you're interested in multi-tenancy, or for whatever reason, I think data services are absolutely a must to learn for GORM. So with that brief background to data services, I'm going to do a few demos of the basics of how you work with data services. So I have a little test project set up here, and well, we'll just comment that out for a minute. So what I have here is a bunch of different domain classes, And we have a product domain class, which represents a product. It has many attributes. We also have a club and stadium domain classes. So it's just some test domain classes that we're going to use to perform. And I have set up a basic unit test here, which is a subclass of Hibernate spec, which is setting up a couple of products, in this case, an apple and an orange, that are both type fruit, and one is green and one is juicy. So how do you work with data services? Well, essentially, I can create a product service, and it can use the service annotation. And typically, what you want to do is it's not strictly necessary. You can use service without targeting a particular domain class, but you get more intelligent compilation and implementation of your methods if you define the target domain class. So I'm going to say this is targeting product. And what you can essentially do at this point is write methods that are very much like the static methods that you find on domain classes already. So I can say, product find, and I can say string the name of the product. And what I can then do is I can say given data store.get service, product service. In a Grails application, or one day in a Micronaut application, you will just dependency inject this. But in this case, I'm going to do a manual lookup. And then you can say expect product service find apple type equals fruit. And in theory, what will happen is that GORM will automatically implement, well, that's the theory. I need to do a clean, hold on. Project. That's me for deleting things before a presentation. So run that, and there we go. So it's passing now. So you may think at this point, well, why would I just, why bother? Well, there's actually some why wouldn't I just do, product find by name or whatever? Well, there's actually some very significant benefits to this relatively simple example. For one, GORM will automatically detect the fact that this is a query and will apply the correct transaction semantics. So what GORM does is it detects every single public method that you have, and obviously in an interface, every method is public, but we'll get to abstract classes in a minute. And it sees that this is a public finder, and it goes, oh, wow, this is a find method, and it's a query, and it's not modifying any data. So yeah, this is going to be a read-only transaction automatically for you. So you don't have to worry about applying the correct transaction semantics to your whatever code that you're using. It just does it for you out of the box. You can, of course, override that if for some reason you wanted to configure your exact transaction semantics. You can override and put a transactional annotation on there, and customize your isolation level and do whatever you want to change your transaction semantics. But the defaults are normally the correct defaults in this case. So the other thing that's interesting is this is a find method, and if I were to misspell, the product domain class here has a name property, as you can see. But if I was to misspell the name property, what you would get is a compilation error. says, sorry, I can't query that property. No property exists, cannot implement for argument name, no property exists on domain class book. So that's a fairly sensible error that you get checking at compile time of your arguments. So what that does mean is you can, have additional arguments in here. So to query for both name and type, I just add that additional argument here, and it just does the right thing, which is pretty neat. You can also, do things like counts. So I can say count number of books for a particular name, and that will, return me probably 1, I guess. In theory, yep. So you can implement counts. You can, in addition, one of the golden rules, actually, I'm not sure if I should, let me step through my slides. So like I said, for that fairly trivial example, in the case of the find method, or in this case I'm using a method called get, and we have some common kind of method signatures that we look for: get, read, retrieve, find, search, that are all like regarded as automatic read-only unless you do something weird. And then we have the equivalent for write operations. So we look for operations like update, store, save, etc., and apply the correct semantics to this operation. So this actually brings me to another example in terms of efficient updates. If you can define update operations, so you can load a particular book by ID, and the ID has to be the first argument. That's one thing, and you can say we're going to update the type, and then you can say I deleted my find method. That was probably not a good idea. Find string name type. And then what you can say is product service dot update. We're going to need it, aren't we? I suppose. I need a reference to that. p.id. And we're going to set the type to, it's not a fruit, it's a computer. And then we're going to say type equals computer. And run that. There you go. Works as we expected. So more efficient update operations. And also, you can do batch deletes. So I can say, void delete all products of a particular type. And this is an example where you need the type of domain class that this data service is associated with, because obviously in the method signature here I don't have any reference to product. So if I just had this, then if I just had that, then GORM couldn't figure out how to implement that. There's no way it would know for sure which type of domain class it's associated with. So this is an example of what I was trying to point out earlier. Is typically you want to associate a service with a type. So this method will essentially do a batch delete of all products of a particular type, allowing you to do really efficient write operations. And again, with this method, you get the correct transaction semantics applied here. Okay, so then, JPAQL is the query language that Hibernate and JPA have defined for querying objects and so forth. And generally, one of the issues with JPAQL and any string-based format is that you are essentially you can open yourself up if you're not very careful to HQL injection attacks or SQL injection attacks. And also, you lose out on type safety. However, the reality is that if you have a really complex update operation, or you want to create really efficient updates, or deletes, or writes, or queries, JPAQL is actually one of the better ways to do that. There are certain queries. We've done our best with all the different query mechanisms that you have in GORM, with detached criteria, with where queries, with finders, with etc., to be as flexible as we possibly can. But there are certain cases that, if you want to create a really optimized query, JPAQL is the way to go. And the only issue is that, like I said, normally historically you've lost a lot of the benefits in terms of type safety, in terms of potential SQL injection attacks. So one of the really cool features of data services is that you can essentially use @query, and you can specify a JPAQL query. And for example, I can say select from product P. And notice how I'm using kind of the string interpolation G strings here to reference directly the product instance. And I can say select P dot, let's go for the type. And the other nice thing is you can kind of spread them across multiple lines, which is kind of cool, which you can't do in Java. Where P dot name equals some value. And you can say product find string name. Now, oops, that shouldn't be implemented, of course. Yeah, I've already got one. Find by type or whatever. So you may be thinking, this is a fairly trivial example. It's not really, representative of anything. But there's some fairly important characteristics here. First of all, because we're embedding the types directly in here, and we're referencing inside the query the types using this $ syntax, your query will actually be validated. So what does that mean? So if I was trying to reference, a property that doesn't exist on product, you can see that I get a compilation error. No property tip existing for domain class product. So I get a sensible error. I get type checking and compilation time checking of my JPAQL and HQL queries, and yeah, which is pretty neat. So and also against my arguments, I've got I'm passing an argument called that should be type find by name. I'm getting confused. So and for my arguments, I'm passing a name argument here, and if I misspelled that or either here or here, again, I would get a compilation error. Sorry, the variable name is undeclared. So at compilation time, we're checking that those queries are actually valid as much as we can possibly do. But the real power of these kind of queries is I'm selecting the type, so I'm saying find type, and that means that you can do optimized fetching. So in theory, this should return fruit. There we go. So because we're we're selecting p.type, we're selecting just the type property, so we're performing a projection and returning only the data that we need. If we were dealing with multiple products, so we could return a list of string, and GORM will obviously intelligently do the right thing in terms of limiting the results to only one result for a non-iterable type, or if you're returning an iterable type like a list, it'll not provide any limits. You can also pass in pagination parameters with if you add like an argument, and in this case, if you do that, you can pass in things like max 100, and just like in normal GORM finders, which is nice. and also, a lot of people don't realize just how powerful JPAQL and HQL actually is. So, for example, you can do stuff like new map as foo p.type as bar. And you can say, this is I want a map, a string, and if we just, I don't care about the assertion right now, I'm just going to print out the value. Well, let's just run the test and see what happens. No, oops, that shouldn't be bar, it should be name. So you can see that what gets returned by my method is a map containing bar and foo, with exactly the data transformation that we want, and only the data that you need. This is really powerful because a lot of times folks lean heavily on GORM, and they just return product or whatever, and whilst in reality, for whatever use case that we're building, we only need a subset of that data. And with things like JSON responses, the map format is converting a map to JSON. JSON is a map, so it makes it very easy to use JPAQL to select only the data you need, and also transform the values into the format that you want, all within a single query, without having to do conversions of your data or getting a book and then transforming it into a map or mutating it somehow. You basically have it done for you by JPAQL in the most efficient way possible, because the underlying SQL select will only retrieve the data that you need instead of retrieving every column in the table that you're querying. So I think that's really an important point. And of course, if you take this approach as well, you're only selecting. You don't have to worry about lazy loading joins. You're only selecting the data you need for your particular use case. So, and in addition to that, that's for queries. And in this example slide, as you can see, we can also do optimized updates. And this is another point with data services, is this add query is using a select. And we have intelligent detection of your JPAQL syntax such that we look at your query and we see, oh, this is a select, okay, this is going to have read-only semantics. If I were to write an update or a delete, so we can say update product p set p dot type equals type, equals type, or whatever, you're performing an extra query here just to get the product, which is an extra round trip to the database, that extra bit slower. If we want to know whether the actual thing worked, we can return an integer here, and it will return 0 if no update happened or nothing was changed, or the number of products that were updated, which may be all that you need to implement your use case. So yeah, optimized writes. I'm running out of time quite quickly. You can do batch deletes, and I talked about joins. If I think a good rule of thumb is if you're going to need the data, you need a join. So make sure that you apply if you have associations and you're going to read those associations, that you apply the correct join semantics. Data services make that really easy to do by using @join. You can say @join attributes and to join a particular association. And if that's not good enough for you, then then you can also use JPAQL to perform more efficient fetches and joins. So this is another example where we're saying, from that club class, we're saying select stadium and capacity in a join stadium. So we're in a joining across the association, and then returning essentially a map of club names to capacities, which is a far more efficient way than trying to read the data and so forth. So yeah, only read the data that you need. You can also do pretty trivial projections. So you can write a method such as find product type, and it infers that type is a property of product, and will return. And if the return type matches the property type, it will perform a projection, returning just the type for any particular query. Again, optimized projections implemented automatically for you. So I probably have just enough time to do a little bit of multi-tenancy demo. I probably shouldn't have deleted all of that code I deleted before. So I'm going to try and roll that back, because otherwise I'm not going to have. Okay, so multi-tenancy. So basically, yeah, it's very multi-tenancy applications where in this test I am bootstrapping Hibernate with configuration to use discriminator-based multi-tenancy. Basically, there are two distinct modes of multi-tenancy that are common. One is data partitioning, which is what we call also is essentially discriminator-based multi-tenancy in GORM. And then you have isolating connections, or so that one tenant talks to one database or one schema, separately. And the latter, isolating sessions and isolating connections, is significantly more complicated than data partitioning. Data partitioning is much simpler, but data partitioning has higher risk of one tenant seeing the other's data, whilst isolating connections is more of a guarantee that it's very difficult as a developer to make a mistake in that mode, revealing data from one tenant to another. So yeah, when isolating connections, different sessions and connections are used for each tenant. And data services are even more important if you're isolating connections, because you essentially have to wrap a different transaction connection around each multi-tenant operation. Each tenant operation has to have its own connection, own isolation, because it's a completely different connection. So GORM Data Services and multi-tenancy are essentially a perfect match. And in this example, what I have here is I've set up a multi-tenancy mode of discriminator, and I'm using the system property tenant resolver. And what that'll do is allow me to switch tenants by setting a system property. Obviously, that you wouldn't use in production, but it's good for testing. And I'm creating a single database. Like I said, in discriminator-based multi-tenancy, you share a single database. So I'm not configuring multiple connections here. And there's basically some setup there to get it running. And over here I have a example of a data service, and you can see that it is annotated with @current_tenant. And what that ensures is that for every single method in the data service, the current tenant will be resolved and applied to that operation. So what that means is, you know, when I get hold of a get book, abstract. This is another thing I didn't mention before is data services can be abstract classes. In this case, I have an abstract class, and I have it has two abstract methods and one non-abstract method, which is really convenient because sometimes you want to compose multiple operations, within a single data service, and you don't want to have to create another class just to do that. So you can instead have an abstract class and mark all the methods as abstract that you want implemented by GORM, and then implement your own logic in your own methods, which is pretty cool. You can see that if I were to comment out this line and run this test, I will get an exception saying, sorry, there is no tenant found, no tenant ID. I attempted to call save books, but you can't save books with those titles because there's no current tenant associated. If I set the tenant, then save some books, then and I get a book, then the title of the book will be blah. Now in this case, essentially every single operation is associated with a tenant called foo. And if I were to then switch to a alternative tenant, and I can do that, like I said, I'm using system property tenant resolver. Typically in production, you would have a tenant resolver that used some approach, whether it be resolving the tenant via Spring Security, or there's a whole bunch of different ways to resolve tenants. You could resolve it from the current user session. You could resolve it from cookies, and we have built-in tenant resolvers for all those approaches. But anyway, if I switch the tenant to a different tenant and try and get hold of, then the other tenant is not going to see that data, right? It's going to see a completely different set of data. Books doesn't exist for the bar tenant. So I have automatic isolation of my my tenants, and GORM will do all the right things. Whether you're using JPAQL queries, it doesn't matter. We apply a filter such that every query is updated to include the tenant ID. Every update, every write is updated to include the tenant ID. So completely, separate views of the data. And the same thing, if I were to configure up here, instead of discriminator mode, you could use, there's different modes. You can partition your database so that each tenant uses a different database schema, which is the schema mode, or you could partition the data such that each each tenant uses a completely different database. And in that case, GORM has to do even more work. For each operation here, we have to resolve the current tenant, resolve the correct transaction manager for that tenant, which apply the correct transaction, wrapping the appropriate connection around each method, such that you're using the right connection for a particular tenant. And there's a whole bunch of extra stuff we have to do for those kind of modes. So it adds an extra layer of complexity which you as a developer don't have to deal with because GORM Data Services are dealing with them for you. Okay, so in summary then, data services are powerful and awesome, and they improve your code maintenance, and if used for the cases I've demonstrated, will also improve your application performance. If you're planning on building a multi-tenant application, then they simplify that dramatically. And surprisingly, yeah, they make JPAQL fun again, which is an achievement in itself. So, and yeah, GORM is going to be nicely and tightly integrated with Micronaut. Although GORM is a blocking API, and Micronaut is a React based on Netty, event loop, and reactive, we have automatic provisioning of all your blocking operations onto the IO thread pool, which is essentially the same behavior you would get if you were running in Tomcat or something like that. So GORM will be, when Micronaut launches, we'll have GORM for MongoDB, GORM for Neo4j, GORM for Hibernate, all working and seamlessly within the Micronaut environment as well, which will be pretty awesome, I think, for folks who choose Groovy for their Micronaut applications. So I have a little bit of time, I guess, tiny bit of time for any questions. Just fire away. I can't see anything, by the way, so yeah.
What about locking? When you need to lock a single flow before performing like an update, you just need to run in the lock method?
Yeah, so JPQL has syntax for applying locks in the query as well. So you can do that. We probably would be nice to be able to have some kind of annotation or something to specify your lock level. So that's a nice feature request. You should file that in. Yeah.
Thanks again for the presentation. And I have a question regarding the hierarchy. If, for example, I have a bunch of different domain clusters, and I need a really huge number of these type of services, but I don't want to repeat myself. I want to make like a proper interface of the class where I will implement a generic method for find, make a common methods find something, update, and whatever. And then I want just to extend this interface. And will this method to be supported by this notation like servers?
I don't see any reason why not. It should work. You can use a generic type and provide as a type argument, and extend another interface.
Do you have default implementations of such kind, like crude repository in Spring, for example?
We don't know, but another nice feature request would be something like that, I'm sure. And a good pull request as well. Yeah.
A short question about, you want to take a list of your products. Can you make a method signature that has a default max and map with attributes?
You can't write. You can provide a map which allows you to specify the max and the offset. It would make another nice feature request for the next version of GORM to allow specific like arguments that are the offset and the max, for sure.
Just a little detail. I was wondering whether the update method you wrote, where you specified the type parameter, was generating an optimized query, update query too.
That one wasn't, because I was returning the type, but if I'd return void, it would revert, because one is doing a find, and then there's like two approaches. But yes, it does. It does.
Last one. Sorry. So what would happen, for example, if we use the JPAQL with an update query, but we name the method by accident find?
With add query, you mean?
Yeah.
For add query, it doesn't matter the method name. It's powered by the annotation. I didn't demonstrate another thing, which is add where, which a lot of people like as well, which is you can define essentially like where queries. But there's a few annotations that obviously when there's no annotation, we have to kind of guess and try and do our best effort to implement the method. And for that, we scan for certain method signatures and so forth. And that's all documented in the documentation, the ones we look for. But in the case of the annotation, we know, so it's up to you what your method's called. You can call it whatever you want. If you want to call it something nonsensical, it's up to you.
We don't have time for more questions, sorry.
Thank you very much.